Hi everyone, my name is Suram and I welcome you all to my YouTube channel. In today's video, we are going to discuss about the numericals of standard 10th, chapter number 2, work, power and energy. So let's start. Practice problem 1. First numerical, a girl of mass 50 kg climbs a flight of 100 stairs, each measuring 0.25 meter in height and 20 seconds. Find A part force acting on the girl, B part work done by the girl, C part gain in energy, and D power in watts and horsepower. So value of G is given 10 meter per second square and H is given 1 horsepower is given 750 watt. So here we have the solution. First A part force acting on the girl, that is equal to the weight of the girl M into G. So M is given, that is 50, and G is given 10 meter per second square, so it will come out to 500 Newton. Then we have second part, B part, work done by the girl. That work done we have in the formula force into displacement. So force is 500 Newton, just now we have calculated, and displacement is total are 100 stairs and each stair is of 0.25 meters. So this displacement will be 100 into 0.25 meter. So it will come out to be 12,500 joule. Then we have gain in potential energy in the C part. So gain in potential energy is equal to the work done, because work done gets stored as the potential energy inside the object as it is raised to the height. So total work done, as we have calculated already, it is 12,500 joule. Then power in watt first. So power in watt or joule per second. So power is simple, having the formula work done over time. So work done we have calculated already, and time is 20 seconds, that is given in here in the statement. So it comes to be 625 watt. In horsepower, in 1 horsepower we are knowing it is 750 watt. So if we talk about the 1 watt here, so 1 watt will be equal to 1 over 750 horsepower. So 625 watt will be equal to 625 into 1 over 750 horsepower. So it will come out to be 0.833 horsepower. Then second, we have a load of 220 kg is vertically pulled up by a crane through a vertical height of 16 meter in 40 seconds. Calculate A part force acting in the upper direction, B part total work done, and C horsepower of the engine pulling the rope. G in this case given 9.8 meter per second square, and horsepower is again 750 watt. So let's have the solution. Work done acting in upper direction, that is equal to the weight of the load, that is equal to M into G. M is, in this case, M is 220 kg and G is 9.8 meter per second square, so it will come out to 2156 Newton. If you talk about the total work done here, so total work done is equal to force into displacement. Forces we have calculated 2156 Newton and distance is 16 meter, so it will come out to be 34,496 joule. Horsepower, that is power of the engine in horsepower, so that is work done over time. So work done is already we have calculated here 34,496 joule, and time is 40 seconds, and if you need to calculate in horsepower, then we have to divide it 750 also. So this will come out to 1.149, or up to 2 decimal places it will be 1.15 horsepower. So next we have practice problem 2. A work of 1000 joule is done in a body in 4 seconds, on a body in 4 seconds, so that the displacement of 20 meter is caused. Then we have to calculate the force and power. So here we have the solution. Work done is equal to force into displacement. Force we need to calculate, work done and displacement is given in the statement, so that we have to put the values. Then force will come out to be 1000 over 20, that is 50 Newton. And if we talk about the power here, power is equal to work done over time. So work done is 1000 and time is 4 seconds, so it will come out to 250 watt. Simple it is, just you have to put the values. The next we have number 2. What force must be applied to a body through a distance of 10 meter so that it does a work of 4000 joule? If the mass of the body is 20 kg, what is the acceleration of the body? Here we have to calculate the acceleration also. Then here we have the solution. Work done is equal to force into displacement. Again we have to calculate the force first, and force is same formula, work done over displacement. So 4000 over 10, that is 400 Newton. Force is 400 So as according to the Newton's second law, force is equal to mass into acceleration. So we have to calculate the acceleration here. Mass is already given. So 400 is the force, 220 is the mass. So acceleration will come to be 400 over 20, that is 20 meter per second square. That is the acceleration. So simply you have to put the values and calculate the acceleration. Then next we have number third. An engine of power 200 watt operates for 4 seconds. Find the work done by the engine. If the force doubled by the engine is 100 Newton, calculate the maximum displacement caused. So here we have power of the engine is equal to work done by the engine over time taken. So work done we have to calculate here. So power is 200 watt and time is 4 seconds. So work done will come out to be 200 into 4, that is 800 joule. And the displacement we need to calculate. So we have the formula for work done. Work done is equal to force into displacement. So simply put the values of work done and force, then you can calculate the displacement. So displacement is 800 over 100, that is 8 meter. Then we have the practice problem 3, first part. Calculate the horsepower of the motor of an elevator which can carry 10 persons of average mass of 60 kg through a vertical height of 20 meter in 30 seconds. G is given 10 Newton per kilogram. So solution is total mass of the 10 persons, because one person is having the mass 60 kg, so 10% is having 600 kg. So work done by the motor, that is mgh, because it is raised to the height. So mgh is value of m is 600 and g is 10 and h is 20. So this will come out to be 1,20,000 joule. Then horsepower of the motor means power of the motor in horsepower. So work done by the motor over time taken. So work done we have calculated 1,20,000 over 30 into 750. So this will come out to be 5.33. It will come 33 every time. So horsepower, 5.3 horsepower we can say. Then second part, calculate the power of an electric pump in horsepower which can lift 2000 meter cube of water from a depth of 20 meter in 25 seconds. G is given 10 meter per second square and 1 meter cube of water is given 1000 kilogram. So here we have mass of water, 1 meter cube is equal to 1000 kilograms. So 2000 meter cube will be equal to 2000 into 10 over 3 kilogram. So work done lifting the water, that is again having the formula mgh. So m we have 2 into 10 over 6 into 10 into 20. So 2 into 2000 into 10 power 3 can be written as 2 into 10 power 6 kilogram. Value of G is 10 and H is 20. So this will come out to 4 into 10 power 8 joule. And horsepower of the electric motor means power of the electric motor in horsepower, that is work done by the electric pump over time taken. Work done we have calculated here 4 into 10 power 8. Time is 25 minutes, so 25 into 60 seconds. And horsepower 750 watt. So this will come out to be 355.55 horsepower. If you solve this, 3 zeros will cancel and we have to divide this. Then it will come out to 355.55 horsepower. Then next we have number third, calculate the height through which a crane can lift a load of 4 ton when its motor of 4 horsepower operates for 10 seconds. G is given 10 meter per second square. Here we have the solution. Let it raise to the height h. So 1 horsepower is 750 watts. So 4 horsepower will be 750 into 4, that is 3000 watt. So power of the crane is equal to work done by the motor over time taken. Power we have in the formula work done over time. So symbol just work done in this case will be equal to mgh because it is raised to the height, and just put the values. H we have to calculate here. Power is this 3000 and mass is 4000 kilogram because 4 ton is given. 1 ton is equal to 1000 kilograms, so 4 ton is 4000 kilogram into 10 meter per second square into h over 10. So h will be equal to cross multiplying 4000 into 10 into h is equal to 3000 into 10. So h will be 3000 into 10 over 4000 into 10, that is equal to 0.75 meter. Zeros will cancel, only 3 or 4 will left, so 3 or 4 is 0.75 meter. Then we have number 4. For how long must an electric motor pump of 2 horsepower operate so as to pump 5 meter cube of water from depth of 15 meter? G is given 10 Newton per kilogram and 1 meter cube water that you are knowing 1000 kilogram. So here we have the solution. Let the time taken is equal to T. Mass of the water at it is given 5 meter cube. So 1 meter cube is 1000 kilogram. So 5 meter cube is 5 into 10 power 3 kilogram. So work done in lifting the pump, that is again mgh, that is 5 into 10 power 3 kilogram into 10 into 15. So this will come out to 75 into 10 power 4 joule. Then power of an electric pump, that is given as work done by the electric pump over time taken. So that is equal to T. We have to calculate here. Just put the values of power of electric pump, that is 2 horsepower. So 2 horsepower means 2 into 750 watt. And work done by the electric pump that we have calculated here, 75 into 10 power 4 joule, and T we have to calculate here. So T will come out to be 75 by cross multiplying 75 into 10 power 4 over 2 into 750 watt. So that will come out to be 500 seconds. 2 zeros cancel, 15 5s are 75. So 500 seconds. Then we have practice problem 4, number 1. An electric pump is 60% efficient. 60% efficient means 60% energy is useful and is rated 2 horsepower. Calculate the maximum amount of water it can lift through a height of 5 meter in 40 seconds. G and horsepower is given. Then we have the solution. Let the amount of water lifted is equal to M. So energy supplied by the electric motor, that is equal to P into T, power into time, because power is equal to work done over time or energy supplied by time. So it is equal to 2 into 750. Why is 2 into 750? Because 2 horsepower is given. So it is 2 into 750 into 40. Time is 40. So it will come out to 60,000 joule. And how much energy is the useful energy? Useful work done with the electric pump, that is equal to 60% of 60,000. That we have to calculate 60,000, 60% of 60,000. That is given here 60% efficient. So 60% of 60,000 will be 36,000 joule. So work done by the electric pump to lift the water up, that is equal to mgh. So this work done is equal to this work done. Is it? These two work done will be same. Is it? So by the law of conservation of energy, M into 10 into 5 is equal to 36,000 joule. So M we have to calculate here. So 36,000 over 10 into 5. So that will be 36,000 over 50. That is come out to be 0 and 0 cancel. So it is 750. So 720 kilogram. Then we have next, calculate the time for which a motor pump of 10 horsepower and efficiency of 80% must be switched on so as to pump 20 meter cube of water through a vertical height of 20 meter. Again, the density of water is given 1000 kilogram per meter cube, and G is given 10 meter per second square, and 1 horsepower is 750 watt. So let's have the solution. Let the time taken is T, and energy supplied to the motor pump, that is equal to, again having the formula, power into time. 10 horsepower is given, so it is 10 into 750, and time is, we have to calculate, it's equal to T. This will come out to be 7500 into T. So useful work done in this case is 80% of 7500 into T. And how much useful work done is done? Useful work is done to lift the water up, that is equal to mgh. So M is 20 meter cube. So 20 meter cube is 20 into 10 power 20 into 10 power 3, or 20 into 1000 kilogram. Into 10 is given, G is given 10 meter per second square, and H is 20. So 4 into 10 power 6 joule is the answer by solving this. Then we have, by the law of conservation energy, these two energies will be same again. 80% of 7500 into T, and that is equal to 4 into 10 power 6. So T will come out to be 80 into 750. This will go down and 100 will go up because of the cross multiplication. So this will come out to be 2 zeros cancels, and 4000 over 6, that is equal to 666.67 seconds. That is the answer. In third, in a hydroelectric power station, 1000 kilogram water is allowed to drop from through a height of 100 meter in 1 second. If the conversion of potential energy to electric energy is 60%, calculate the output power. So power output, that is equal to work done over time. So work done in this case is mgh. So simple, put the values. 60% of potential energy is converted. So 60% of potential energy is converted into electric energy. So power into 60%, power over 60%, that is 100 over 60, that is equal to m, we have in this case 1000, g 10, and h is 1000, and time is h is 100, and time is 1 second. So power will come out to 10 to the power 6. If you solve this, it will be 10 to the power 6, because it will come the 6 zeros, 1 2 3 and 3 6. So it will come out to 10 to the power 6, and this 100 over 60 will be 60 over 100 on this side, right side. So this will come out to is 6 into 10 to the power 5 watt. Here we have the practice problem 5. A compressed spring is held near a small toy car of mass 0.15 kg. On the release of the spring, the toy car moves forward with a velocity of 10 meter per second. Find the potential energy of the spring. So here we have the solution by the law of conservation of energy. Kinetic energy is equal to potential energy, that is equal to kinetic energy of the toy is half mv square. That is the formula for kinetic energy. Mass into velocity square, half mass into velocity square. So mass is 0.15 kg and velocity is 10 meter per second, and it is whole square. So simply just solve this, it will come out to is 7.5 joule. 10 into 10, that is 100. So 2 into 100 divided by 2, that is 50. So 50 into 0.15, that will come out to be 7.5 joule. Then we have number 2. A catapult throws a stone of mass 0.10 kg with a velocity of 30 meter per second. If 25% of the potential energy with the elastic band is wasted during transmission, find the magnitude of the potential energy. 25% of energy is wasted here, is it? So we need to calculate the useful energy. So here we have wasted potential energy is 25. Then how much is the useful potential energy? That is 100 minus 25. Total is 100. So 100 minus 25, that is 75 is the useful energy. So 75 of the useful energy of potential energy, that is equal to kinetic energy, half mv square. So 75% of potential energy is equal to half m is 0.10 and v is 30. And potential energy is equal to 75 over 100, that will cover to be 100 over 75 on the other side. Here is 30 into 30. So 30 into 30 is 900. So it will be 1 0 will cancel here, so it will come 90 over 2, and on this side, from left side 75 over 100, it will be 100 over 75 on the right side. So when we solve this, it will come out to be 60 joule. 90 over 2 45, and 100 over 75 4 over 3, so it will come out to be 60 joule. Then we have practice problem 6. A body A of mass 20 kg is moving at the velocity of 1 meter per second, and another body B of mass 1 kg is moving by the velocity 20 meter per second. Find the ratio of the kinetic energy of A and B. Here we have to calculate the ratio of the kinetic energies. So simply just take the ratios of kinetic energy of A, ratio kinetic energy of V. So kinetic energy of A, that is half mv square. Half m for A is 20, and the velocity of A is 1. So kinetic energy of V is half mv square again. square, and kinetic energy of the wooden target is half mv square. So we need to calculate v here, velocity of the wooden target. So simply would put the values. Mass of the bullet is 0.2 and velocity is 200, and mass of the wooden target is 5. So we have to calculate the v square here. So it is 5v square, 1/2 cancel. 5v square is equal to 0.2 into 200 square. So 5v square is, v square is 0.2 into 200 over 5. So it will come out to be 40 into 40. So this will be v square is equal to 14 square. So square and square cancel. So v will be 40 meter per second. So this was all about these 6 practice problems. Next 7 practice problems are left that we'll solve in the next video. Thank you.